All right, looking at this table, I asked you to write down the table, and it says to fill in the missing values in the table. First off, it says as x, and then this column on the other side says x squared. If I go down here to where x is 3, what is x squared? So what is 3 squared? 3 times 3 is 9. What if I went backwards here? Like what number squared gives you 1? 1, because 1 times 1, remember this is the same as 1 times 1 is 1. What about here for 4? 2, because 2 times 2, which is 2 squared, gives you 4. If I go down and we've already did 3, 3 times 3 is 9, remember, because that's 3 squared. What about here for 16? 4, 25, 5, 6, 6 times 6 is 36. And the next one down here would be 7. Because all of these numbers right here times itself give you these numbers over here on the right. Okay, I'm not going to go through those other ones. Let's look at the next slide. Now, I want you to look at this. Let's look at these patterns of these exponents. It says fill in the values for the powers of 4 below. What pattern do you notice? So right here, 4 to the 0 power. Put in your calculator 4, caret 0, press enter. And then I want you to put 10, caret 0, enter. Pick any number and put it to the 0 power. Press 4, and then the caret button, 0, and press enter. What do you get? If you're getting an error, Miss Dawson will be around to look and see what's happening. 4 to the 0 power is 1. Anything, any number to the 0 power is always 1. It could be 100 to the 0 power, and that's 1. That's a reminder of what we did during our exponent unit. Now, what about 4 to the first power? What do you get there? 4. 4 to the second power? 16. Remember, that means 4 times 4. What about 4 to the third power? Now, how did you get 64? 4 times 4 times 4, because 4 times 4 is 16, then 16 times 4 is 64. Some people try and make the mistake of doing 4 times 3 and getting 12. Please remember, that's not what the exponents mean. Look at this one. It says, fill in the missing value below. This is brand new, so just take your best guess. I want you to look at this, and what do you think? Put in there, what do you think that would be? Don't put it in the calculators. Well, you can. All right, so people are saying 2, 2, 2, 2. It's 2. Okay, got it. 4 to the 1/2 is 2. Now, I want all of you to back away from the calculators and set them down, and to try this the next way. Ready? I want you to look and see if you can use the same pattern for these other powers, then check your results in the calculator. So wait, stop pressing the buttons. I'm asking you right now to fill in what you think the answer is. So right here, write them down. I want you just to write them down. Do not use a calculator. Use your best guess right now. Write them down instead of saying them out loud. Now, after you've taken your best guess, now put them in the calculator and see if your answers were correct. So as you're looking, I have a feeling I know when if you made a mistake, what your mistakes were. And that's okay to make the mistake. You were kind of set up to that.
Oh, so the half is say for 16, it's like what equals that?
All right, come back together with me. Ready? Here is what I know quite a few of you did, and it is just fine. You thought that 9 to the 1/2 was 4.5. Because what you did was take half of 9. You divided 9 by 2. But when you put it in the calculator, what did you get? You got 3. And then 9 to the first power is 9. Now, when you went to 16, most likely you thought it was 8. But what did you find out that 16 to the 1/2 was? 4. 16 to the first power? 16. Again, 25, you thought it was 12.5. And really, when you put it in the calculator, it was 5. Now, look at the next slide. What's the pattern you notice? Up on the board, look at what's happening. When my exponent is 1/2, what is actually happening? Are we dividing it by 2? We're not dividing it by 2 because 25 divided by 2. Michael, that is what we're doing. We are finding the square root of that number. See, what you're going to find, pay attention to what I'm saying. What you're going to find is that 1/2, what that actually means, well, I guess I'll write it up here. 1/2 is the same as the square root sign. So when I write 25 to the 1/2, that's the same as taking 25, the square root of 25. We're going to get there in just a minute, but hold on a second. These numbers, look, in that table that we drew, we wrote up back here. Let me find it. Where'd it go? All of these over here. See how I said 1, 4, 9, 16, 25, 36? All of those numbers are are what's called perfect squares. Why do you think they call them perfect squares? It makes an even number when you try and take the square root of it. Because what number times itself gives you 25? 5. So 5 squared gives you 25. 25 is a perfect square. What about 49? 7. So it's 7 squared. What about 81? 9 squared. And then there's 11 squared. Can you name some other perfect squares? 10's not a perfect square, but what would give you, what it would be 10 squared? It'd be 100 is what's the perfect square. What's another perfect square? 4 is, because that's 2 squared. What's another one? That is a great question. A negative cannot be a perfect square, cannot be a square root, because you can't have a negative underneath the square root sign. That's actually called an imaginary number that you will do in Algebra 2. That's a great question. Give me another, just one more perfect square. What else do we have? We do have 9. 9 is 3 squared. Okay. Now, it says, what is special about the base numbers 4, 9, 16, and 25? What are some other numbers we could use to make a neat 1/2 power? That's what we were talking about when we went through and did, saying that 36 to the 1/2 is 6, because that's the square root of 36. Let me move on from this slide and go to the next thing. I want you to look, and you guys need to remember from 8th grade. If 3 squared is 9, then the square root of 9 is 3, because the square root of 3 squared is 3. Okay, so what it's saying in all that, look, 3 squared equals 9. The square root of 9 is 3. Basically, here's what happens. Just like multiplying is the opposite of dividing. Adding is the opposite of subtracting. The square, taking a square, like to the second power, is the opposite of the square root. Okay? So just understand that the square root and something squared is opposites. Now, the square root of a number is one kind of radical. It's a special family of numbers. Here's what I want you to notice. First off, I'll come to this little bubble right here. But this little check mark looking thing is called the radical sign. The number underneath is called the radicand. Now, when I was writing the square root, did you see me putting a 2 right here, like here? No. When you have the square root, you don't have to write that there. Just like when we write the number 9, it's 9 to the first power. 9 to the first power, we don't write it like that. It's just 9. Okay? Same thing with your square root sign. You don't write the 2 on there. This is 9 to the first power, which is 9. No. Hold on a second. When we're talking about why this is here is because, look what we did on the last problems. When I had like 9 to the 1/2, right? That's the square root of 9. We just didn't put the 2 right here. The 2 goes here. The 1 goes right here. Now, I think it's on the next slide. Hold on a second. Okay, yes, so look here. It says connecting the fractions to radicals. Consider the following. What part is the same as what is different? So as you look at this, look here. Square root, instead of writing square root, I can write it as a fraction, which is 1/2. On the square root, though, we don't see the number 2. But that's where this number right here is coming from. Again, I said that the square root and a square is an opposite. That's why those cancel each other out and they become a. The reason why this happens is, remember that when we had the rules, when I said 3 to the second power and then we went to the fourth power. What was the rules of exponents? What do you do with these exponents? Do you add them, subtract them, or multiply? You multiply. This is 3 to the 8th power. So I'll come back to this in a second. So if I have 2 to the 3rd power, then to the 4th power, what would that be? This right here is 3 times 4, which is 12. 2 to the 12th power. Well, if I had 2 squared to the 1/2, what is 2 times 1/2? It is 1. That's 2 to the first power, which is the same as 2. We know that 1/2 is a square root sign. See, we'll come to this in just a second. Now, let me go back here a second. Let's see where to go. All right, let me move on down. Any square root can be rewritten as an exponent. See right here, the square root of x is x to the 1/2. So now, looking here, right here, 4 to the 1/2 is the same as the square root of 4. What is the square root of 4? The square root of 4 is 2. What number times itself gives you 4? That's 2. Right here, 9 to the 1/2 means the square root of 9. That means 3, because the square root of 9 means what number times itself gives you 9. Right here, this time I'm kind of going backwards. I need to know the square root of what number will give you 4. That is 16. Now, Instead of the square root sign, we can write it with an exponent of 1/2. So that 16 to the 1/2 power is the same as the square root of 16. This one here, this would be 25. And if they didn't write it with a square root sign, it would be 1/2. So it would be 25 to the 1/2, and that's why it gives you 5. Again, here, 36 to the 1/2 is the square root of 36, which is 6. Now, take a second and fill in these blanks. Think about what it's saying, and we'll come back together and see how you did. Okay, so look at this. Right here, it says the square root of 4. Instead of 4, you can write it as 4 is 2 to the second power. Now, the square root and the squared are opposites. So like basically the squared takes away the square root, and that's how I have 2. When I look at 9, I can rewrite it as 3 squared. So the squared can take away the square root, and I have 3. Looking here at 16, you would have the square root of 4 squared. The squared gets rid of the square root, so you have 4. What about in here? In the blank, it would be a 5. 5 squared is 25. The squared gets rid of the square root sign, and that's why it's 5. This one would be 6 squared, and then it would be the square root of 6 squared is 6. This one down here, it would be the square root of 49 would give you 7. These are many different ways of writing the same thing. Just like on your state tests and on the EOC, you have to know how to write it in various forms. Now, so as I look at these, okay, we've gone through and done these on the other one right there, but look at what it added. When you have 5 squared to the 1/2, and that's when I talked about that multiplying, that's why it becomes 5. I'm not going to really pause on this. I'm not going to really go over this because I really kind of already touched on it. All right, so right here, what about number 2? Write that down. Number 2, first write it with the square root sign, and then write your answer. Put that down now, please. So 25 to the 1/2 means the square root of 25. What is the square root of 25? 5. So what if we had this one? But how do you write it first in the square root sign? Square root of 10. Oh, not 10. Woo! Square root of 100, which is 10. What about these two? Write down these two with what you think it is. Let me give you just a minute to do it instead of blurting it out. I feel like I have more than the 5 voices that I normally hear in my head. I've got about 15 of them yelling at me. I might need to go to my therapist for more sessions. Okay, wait. So the first blank right here is a square root of 225. Somebody told me what that was. It's 15. Okay? How could I write the square root of 64 with an exponent? 64 to the 1/2, which is 8. What about, now, somebody had asked me in the other periods, what about if I had the square root of 20? Can I break up 20 to where they at least give me one perfect square? What numbers multiply together to give you 20? What's a perfect square, though? We talked about 1, 4. Okay, we got 5 times 4, right? So we could have the square root of 5 times 4, which is the same as saying the square root of 5 times the square root of 4. The square root, we know what the square root of 4 is, right? What is that? No, not 16. What's this? 2? 2, and then you have what's left is the square root of 5. This would be your simplified answer. Let's look at another one. Yes, sir. Okay, the question was, will there ever be decimals? If I went through and put this in the calculator, it would give you a decimal answer. In geometry and in algebra 2, you're going to find that they're going to want you to leave it in the square roots, okay? And they don't want the decimals, all right? What if I had, let me think of a good one, the square root of 18. Does the square root of 18 work out perfectly? Is that a perfect square? Is there a number times itself that gives you 18? 9 times 9 is 81. There's not. It's not a perfect square. But we can simplify it. See, I've lost about 5 of you right now. What number does multiply together to give you 18? 6 and 3 does work, but neither one is a perfect square. What about 9 and 2? Okay, so I would have the square root of 9 times 2. So I have the square root of 9 times the square root of 2. What is the square root of 9? 3. And then you write what's left over, the square root of 2. Yes. Like which one you put first? Here or down here? Up here? No, it does not matter. What I'm doing is I'm taking my numbers that aren't perfect squares and I'm trying to find if a perfect square goes into it. Okay? And then you find that square and you write what's left. So what about, let me think of another. Yeah, yes, you asked, is that the answer? This is the answer because it's all we're doing is simplifying. Okay? Right. Huh? Yes. Answer what? Rarely, the question was, will it ever be an answer in a fraction? Rarely will they write this like mathematically, you could write it as 3 times 2 to the 1/2, but they rarely will write it like that. When you see those 1/2s and stuff, it'll be in the original problem. Okay, well, let's look at this one. How about the square root of 72? Okay? Now, the perfect square, now that it's not a perfect square because you got 64, which is 8 times 8. 9 times 9 is 81. So this is in between those. So it's not a perfect square. Now, if you don't like doing the perfect square thing that I was showing you, this will lead into what we're doing tomorrow. Now, what I do is I go through and I figure out the numbers that multiply together to give me 72. So what, off the top of my head, I know 9 times 8. Okay? Then I know 9 breaks up into 3 times 3. 3 is the lowest it can go. I kind of put lines underneath of it so I don't forget. Now 8. 8 breaks up into 4 and 2. I can't take 2 any farther, so I put those lines underneath there. Now the 4 can break up into 2 and 2, right? Okay, so all those numbers I put the lines underneath of. I'm going to write all of those underneath the square root sign. So let's see, I've got 3 and 3. I've got 2 and 2. And then I have another 2. Now, can you see why I would put lines underneath when I finished it so that I didn't forget one of them? Okay? All right. I should have the song. Tomorrow we'll have the song. Anybody know the song by Rob Bass? It takes two to make things go right. Okay. Anyway, I got this little square root sign is like a house. It takes two to come out the house. So it takes two of these threes to come out the house. So now I've got 3 outside. Do you see another set of 2? I see 2's right here. It takes 2 to make things go right. All right, so it comes out. And what's left inside? That 2 has no friend and is grounded and can't go outside and play. Now, let me finish. Hold on a second. So now, multiply these 2 numbers that are out here, and I get 6 square root of 2. That's one way. I'm sorry, I didn't hear the question. Did you answer it? Okay. Now, if you did it the perfect square way, the way I was doing it a little bit ago, square root of 72. I know that that is 9 times 4 times 2. Does anybody see the square root, the perfect squares in here right now? I need your focus for just a couple more minutes. Look, I broke this up. Look, we had 9 times 4 times 2. Underneath this, right here on the square root sign, do you see the perfect squares? Isn't 9 a perfect square and 4? If I broke it up like square root of 9, square root of 4, and the square root of 2, what's the square root of 9? 3. That's how the 1, 3 got pulled out. What's the square root of 4? 2. That's how the 2 got pulled out. And this one was all alone and got left and was grounded. So, and had to stay inside. Now, when you pull them out right here, that's why they multiply. Yes. If none of them can be perfect squares, then there's nothing you can pull out. So you just leave it as a number. So, for example, in your question, if I said, what is the square root of 11? Is there any numbers besides 1 and 11 that can multiply together to give you that? Nothing. This is as low as it goes. Yes, ma'am.
On the other one, how can you put 8 in there?
On this one, I took 8 and broke it up into 4 and 2 so I could find another perfect square. Okay? All right. Let's try it. Let me find my problems that I want y'all to do. Ready? There's 4 problems. Number 1, I want you to try and find, let me write it here. Number 1, I want you to write this. Please simplify these 4 problems. Write them down right now. Well, golly gee williker, there's 2 2s. All right, let's try number 4. Let's see if I can count it better. All right, so I want you to try and do these 4, and then let's see how we did. All right, look at number 1. If I did this, I could rewrite it like the square root of 16 squared. What did I tell you the square root and the squareds were? They were opposites, right? They cancel each other out. So your answer to number 1 should be 16. Okay?
Wait, didn't you do the square root of it?
You don't do the square root of 16 because, okay, hold on. You're talking while I am. Hold on. The square root is, if I rewrote it like this, square root of 16, right? Square root and squareds, you can kind of think of it as they're opposites. They cancel each other out. Or look at this. If we do power to a power, we multiply the exponents. 2 times 1 is 2. 2 times 1 is 2. And that would be to the first power. So the answer is 16. Now number 2 9 to the 1/2 means the square root of 9. What's the square root of 9? 3. Your answer should have been 3. Now on number 3, this was what we did just a minute ago. I would have split this up into a couple different ways. Maybe you could, if you found 16 and 2, that was actually the fastest way. Because the square root of 16 and the square root of 2, if you didn't do it this way, if you still did it the other, you would have been able to do it step by step.
You could do 8 and 4.
You could do 8 and 4. Okay, I'll show you in a second. But here's the thing. Square root of 16 is 4. So you should have come up with 4 square root of 2. Now, let me go and do this one real quick over here. Now, if you did the square root of 32, and Torn, you said you did 8 and 4, right? All right, well, that's fine. This is a perfect square, right? Square root of 4. But you couldn't have, if you did this, 2 square root of 8, you had to break 8 down again. And so then you had to break it down into 4 times 2, which gives you the square root of 4 again. So it'd be 2 times 2 times the square root of 2, which still gives you 4 square root of 2. Did you get that? Or did you leave out this part right here?
I didn't do that part. I just did it.
Did you get this answer right here?
Yeah, I got that.
Okay, and you have to look. When you do that, you have to look and see, can I do it again? Can I get another perfect square?
Basically, trying to the lowest.
Yes, it's like getting it to the lowest terms. Uh-huh. So now, over here, 60. All right, now 60, I could do this. Let me just put it on another page. All right, well, let's try 6 and 10. If I split it up as 6 and 10, that's still not, those aren't perfect squares, and it's not lowest terms.
24.
I've got, no, look here. So now 6, I've got 2 times 3, that's as low as they go. What about 10? Exactly, that's as low as they go. So as I write this, I've got 2 times 3 times 2 times 5. Is there a pair that can come out the house? I've got 2 2s. They come out the house. So I get 2, but what's left underneath the square root sign? 3 times 5, which is what? 3 times 5. So that gives me 2 square root of 15. Hold on. If you do the square root of 60 and you talk about a perfect square, that is also 4 times 15. The square root of 4 and the square root of 15. That's also how you can come up with 2 square root of 15. We will be doing more tomorrow on square roots.